Hey guys, welcome. If you missed me narrating over my videos, well, I hope you are now satisfied, and I hope that everyone is well and that you are protected by my amazing Father and Savior Jesus Christ, who is with me no matter the weather. It's actually a little bit rainy outside right now, but a good rainy morning in New York City. But yeah, I hope Jesus is with you, through thick and thin as he's with me. But yeah, so here I have a really fun problem that I want to share with you, and I call it the fun water vase problem. And I'll give you details about the problem in a second. But first, let me tell you where it comes from. It comes from MFA, Math for America, and for any future math teacher who has a solid math education, this is a really good program to enter. And initially, it was only in New York City, but it's now more popular all over America. So it's what is it, grown to serve the larger U.S. community. And what it is basically they have a requirement for how many math courses you need to have taken in college. You don't need to necessarily be a math major, and I think they've expanded to science people now. You can learn more by Googling Math for America. But anyway, what they do is they give you stipends to teach in public schools, and it used to be a large stipend. And even if you are not a new teacher, which is what the program is mainly for, and it may have again changed a little bit now, you do your own research. But yeah, even if you're not a first time teacher, if you're already a teacher in a public school, they have master teachers, I think is what they call it, where they give seasoned teachers stipends to continue being in the classroom in public schools. That's the catch, is that you have to be a public school teacher. But yeah, this is a super mathy program. As you can see, they have some sigma expression here, right next to their logo. But yeah, it's a community of super talented math people, or people who are really interested in math and have some competence in it. And I think for a master teacher, they give you a $15,000 stipend per year. But yeah, look into the program. It's really fun. And circa 2004, this problem appeared. So obviously to enter the program, you have to do a little bit of math, which is in the interview, the questions are all math. In fact, on one fun interview, they have a bunch of mathematical numbers, including the golden ratio and pi and e and all sorts. And they ask you to pick from the bunch and talk about everything you know about that specific number. So it's a really, really fun program. And also, you have to take what's called the Praxis Exam. And so the Praxis Exam comes in two ways. One is kind of like the regular SAT, so there's a regular Praxis. And then just like how there's a math subject test for the SAT, there's what's called a content knowledge specific category of the Praxis. And that test is really, really fun. I sat for it, and if you're someone who loves math, you really enjoy taking the test, as I did many years ago. But anyway, enough said about the program. And so when you first apply, they ask you math questions. And as I said, this was a math problem that was posed to anyone who was applying to the program circa 2004. And the question goes a little something like this. Yeah, so I had to pause to let an ambulance pass by. I don't know when the noise pollution in New York City is gonna stop, but they should dig tunnels specific for ambulances and whatnot, and that way they both solve their own problem of getting to their destination efficiently, and they stop the noise pollution. But anyway, I digress. So this is a nice little break from doing integrals, but yeah. Before I pose the question, I suppose I should get our figure going. So obviously the answer to the question depends on the shape of the vase. So this vase is supposed to be symmetric about the horizontal where it's widest. And so, like, I have this specific vase right now, and I believe the question posed on the Math for America application was on a vase exactly like this. And so, like, you have this vase, and you're going to let water into the vase at a constant rate. And for reasons you will understand shortly, I'm going to draw some cross sections to the vase. So let's pause and like let that go, like we just let that going, let that go going, let that I don't even know, like I can't speak English. Let the picture be drawn. All right. So I've color coded some circular cross sections, horizontal cross sections of the vase, so that the green cross section is supposed to be like symmetric, again about the horizontal where the vase is widest, to the other green circular cross section on the top, and so the white will also have a symmetrical cross section on top, and these are going to turn into points on our graph. But again, let me pause and let the drawing kind of render or whatever. And yeah, hold on. Okay, so we've got our axis going, and vertical is the height and horizontal is the time. So now you should get a sense of what we're trying to do. One more cross section there, right in the middle. So the question is, as I said, if water is coming into the vase at a constant rate, what would the graph of height versus time look like on the water height as water is going into the vase, right? And so, although I don't frequently do this, because I imagine that you're coming to watch my videos because you need the help and you're not trying to figure it out on your own, or you have attempted to figure it out on your own, here's a really fun problem where you should pause the video right now and try to figure out what the graph should look like. And my solution I am very confident about, but it's open to discussion, which is I wanted to share this question so that, if you want to have a dialogue about, further dialogue about it, then I'd be happy to. But yeah, so I think that the graph of height versus time is going to look like this. And I am using these mirrors on this nice tool. By the way, this tool is called Sketchbook Pro, and they owe me money because so many people have asked me about it, and I've told so many people about it. I feel like they owe me money. But anyway, as you can see, I have this mirror and this mirror to make my graph accurate. But obviously, we're not going to need this portion and this portion, which you're going to see that I'm going to delete. So the shape of height versus time graph for this problem, I think, is going to look like the following. Let's fix it. So there. So on the inflection point right there is going to be when the height of the water gets here, right? Otherwise, the green cross sections are going to be also, as I said, dots on our graph, and they're going to be symmetric somewhere about there and somewhere about there, right? Like the height being here and here, right? And then the white ones are going to go somewhere about there and symmetrically somewhere about there. So I think the graph is going to be like a cubic polynomial. Is it going to be exactly a cubic? Well, you tell me. That's, again, why I shared this problem, so that we could have a dialogue about it. But yeah, I think it's going to look like this because, well, first, because as you can imagine, the vase is narrower in these portions. It's going to fill up quickly, and then it's going to die off the pace at which the height grows, right? Because, well, it's going to take more water to get into these spaces, right? The wider cross sections, and then it's going to pick up pace again when it gets to the top narrower parts. And so this is what I think will be an accurate visual. And you let me know if you have a different answer or what you can add to the solution. I hope you enjoyed this, and I hope you have a wonderful weekend. Talk to you soon. Take care.